Ignition sequence start. 5, 4, 3, 2, 1. Liftoff. We have a liftoff.
Good morning, ladies and gentlemen. I'm Kevin Chilton, Explorer Chair at the Mitchell Institute's Spacepower Center of Excellence, and welcome to the release of our newest policy paper, Securing Cislunar Space and the First Island off the Coast of Earth. After decades of relative quiet, we're in a bit of a back to the future moment, and the moon is the goal of a race among spacefaring nations once again. That's why the Cislunar region, the physical space in and around the moon, is so important now. However, things are different than during the bipolar world that existed in the 60s and 70s when we saw our last race to the moon. Today, multiple nations and commercial entities are seeking scientific, security, and economic rewards associated with key regions on the moon and rare minerals from the moon. Unlike the Apollo program, actors are also looking to maintain a long-term presence. This is a new frontier in the classical sense, one we haven't seen for over a century. And it's not just about developing the necessary technologies to facilitate these operations. What's even more important are the standards that will be set for activities on the moon and in the broader cislunar region. We need to ensure peaceful norms are established, akin to what we have in the global commons of air and sea. That's far from a guarantee, given the lack of established international norms of behavior in this region, plus the secretive territorial approaches that nations like China and Russia favor. We don't need to see behaviors in the cislunar region or on the moon like we are seeing in the South China Sea today. This is a major reason why the U.S. and its allies need to return to the moon and the broader cislunar region first. Only by establishing the precedent of cooperative, transparent, and responsible behaviors exemplified by the Artemis Accords can we hope to realize the full benefits of the moon and cislunar space for all humanity. U.S. Space Command and the Space Force are charged to secure national interests in space and must therefore possess the capabilities and capacities to meet this objective. These same capabilities can also play a vital role in accelerating the advancement of peaceful, civil, and commercial activities, much like how the U.S. Navy empowers freedom of transit on the sea. That is why this report is so important and timely. It explains steps the U.S. and allied leaders need to take to set norms of behavior and other key conditions on the moon and in cislunar space. And now I'd like to welcome our panel. First, the author of this excellent paper, retired Colonel Charles Galbreath, the Senior Resident Fellow at the Mitchell Institute's Spacepower Center of Excellence. We're also fortunate to be joined by former NASA Administrator Jim Bridenstine, who led the creation of the Artemis Accords and is intimately familiar with the efforts to return to the moon. We're also pleased to welcome Mr. Tom Lockhart, the Director of Capability and Resource Integration at U.S. Space Command. In this capacity, Mr. Lockhart is responsible for establishing the requirements for the command and advocating for their assigned missions. Last but not least, we have Dr. Joel Mozer, the former Director of Science, Technology, and Research for the Space Force, where he served as the central lead for all science and technology matters for this service. Again, welcome to you all, and thanks for joining us. And Charles, let's begin with you and an overview of your paper. And as a note to our audience, feel free to submit questions throughout this broadcast. And Aidan Poling, our assistant, will summarize those at the end and give you the opportunity to present your questions at the back end of this presentation. Charles, over to you.
Thank you, General Chilton. Cislunar may be a new term to many of our listeners, but with 10 missions headed to the moon in 2024 alone, I think it's going to become part of our everyday vocabulary. As you'll see, the race to the moon and the cislunar regime is no longer just something for the future. It's happening today. Yes, there's been some recent setbacks and some delays, but we at Mitchell believe that this is not a reason to keep the topic on a back burner, but rather a reminder of how difficult it is and why we must take steps now. I'd like to begin by highlighting two very different views of why we should go to the moon. On the right is the famously inspirational message of being up to the challenge. On the left is a fearful message rooted in territorial mindset. We should expect that China will treat the moon and other regions in space territorially, as they have demonstrated time and time again in the island chains of the Western Pacific. The moon, cislunar regime, and beyond should not be viewed territorially. They should be for the common use for all humanity. But the lack of established norms and that territorial mindset put that dream at risk. We wish to have a peaceful, free access for all nations in the commons. But as we've seen in international waters and airspace, that is often threatened. Speaking with several senior Space Force officials, there is agreement of the responsibility for the cislunar mission. But they also view this as a problem for tomorrow and lack the resources to pursue it now. Instead, they must focus their limited resources on preparing for the fight tonight. And I can't argue with that. They actually have to marshal their resources where they can best provide an impact. However, smart additive growth for the cislunar mission now is required. The second race to the moon involves dozens of countries, but clearly pits the values of the United States and its allies against the values of the authoritarian China and like-minded governments. As you mentioned, General Chilton, at the center of the United States' approach is the Artemis Accords, a multinational agreement fostering cooperation and transparency among nations. In stark contrast, the comparison to the moon to the Daewoo Islands heralds territorial claims, weaponization, and regional access denial. Nations around the globe will evaluate the relative success of these two approaches and will in turn impact terrestrial geopolitics and establish precedents for humanity's expansion further into space. For these reasons, the United States and its partners must succeed and establish a more constructive future in cislunar space than that offered by China. We wish we could solely focus on peaceful civil and commercial efforts, but history has shown, and recent events in the Red Sea and South China Sea have reinforced the need to secure and assure access to areas that should be considered international commons. For decades, our focus on space has been about integrating space capabilities and services into terrestrial warfighting and daily life. This will still be important, but we are also beginning to see the increasing development of space-centric interests. As we move from solely thinking about the region of space primarily controlled by Earth's gravity to regions impacted by the moon's gravity or further out by the sun's gravity, we must adjust our thinking. In many ways, this is very much like moving from river or coastal operations to the open ocean. This means that for these new regimes, new capabilities, operational concepts are all required, along with additional personnel and resources that will become essential. But there's a lot of challenges that must be overcome as we head to this new regime. The first obvious challenge is scale. To help illustrate this, I've put up a depiction of an NBA basketball court. You may be thinking, okay, this is a cislunar paper, where is this going? But if we consider that the Earth is the size of a basketball placed just under the hoop on one end of the court, the moon would basically be the size of a tennis ball just beyond the three-point arc line. The geocentric regime that we've conducted most of our operations in would be little more than 2.5 feet around that basketball-sized Earth. As I mentioned in the previous slide, the cislunar regime is impacted by both the Earth and the moon's gravity. This creates points where these factors balance. These are known as Lagrange points and will be very important for domain awareness, communications, navigation, and other purposes. There are 5 Lagrange points in the Earth-Moon system, with what is known as L3 on the opposite side of the Earth from the moon, while the rest of them are basically around that three-point arc line. So this just gives you some indication of how large the cislunar domain is compared to what we've become accustomed to in the geocentric. In addition to the scale, the influence of the moon's gravity makes determining an object's trajectory complicated and incompatible with existing orbit determination models. Further, the Earth-Moon inclination and relative positions with the sun add additional complexity. And the challenges don't stop there. Once you reach the lunar surface, there's a whole other set of challenges that must be overcome. Largely driven by the lack of atmosphere on the moon and magnetosphere, There are several challenges on the lunar surface as well. There's no protection from solar or cosmic radiation. Fine lunar dust or regolith covers the surface and can cause mechanical, electrical, and respiratory issues. There are extreme temperature swings on the 2-week-long lunar night and day. These challenges and others must be mitigated in order for U.S. and partner nations to take advantage of the opportunities in the cislunar regime. But with so many challenges, a reasonable question is, why go there at all? First, there are some national security concerns regarding the potential of trajectories of hostile spacecraft utilizing the gravitational attraction of the moon to then re-enter into a geocentric regime with little or no warning in a domain where we have virtually no domain awareness. There are also potential economic and scientific opportunities as well. Some of these are tied to specific regions and supplies of limited resources on the lunar surface. As a result, the opportunities of the cislunar environment are at risk from the lack of establishment of norms in this new frontier. Challenges and opportunities demand action now to have capabilities when needed. Fundamentally, the moon and the cislunar regime are an opportunity to develop the technologies, practices, skills required to go further into the solar system. So establishing the right precedent at the beginning based on transparency and cooperation is essential. And that is the core of the Artemis Accords. As the image indicates, there are over 30 spacefaring and non-spacefaring nations who have voluntarily joined the Artemis Accords. Nations are agreeing to share information and support the tenets of peaceful cooperation and transparency. Few of the nations I'd like to highlight. First, India, who back in August became the first nation to land near the south pole of the moon and only the 4th nation to land softly on the lunar surface. Next, there's Japan, who has had a private venture that has struggled to succeed, but is also moving forward with civil and commercial activities as well. In fact, I believe they're trying to do a lunar landing later this week. But again, there are a lot of challenges for these nations to overcome, but the technical and environmental challenges that I described earlier aren't the only things threatening success. The lack of established norms in the moon and the cislunar regime, coupled with the territorial mindsets from nations like China and Russia, are also key challenges. Yes, there's the Aerospace Treaty from 1967, which prohibits weapons of mass destruction, military bases, or claims of sovereignty on the moon, and stressing the peaceful use for all humanity. However, there isn't any particular guidance on the use of resource extraction or similar activities on the moon, which means largely that those who get there first will establish the precedent, will establish that norm as they go forward. China, in their efforts, is building a coalition with Russia, Iran, Pakistan, and other nations. And they've, demonstrated their relationship to the moon, to the island chains off the Pacific. And therefore, I think it invites a comparison of what we've seen in the Western Pacific. They've expanded territorial claims, covert militarization, coercive diplomacy, and aggressive behavior are the hallmarks of China in the Western Pacific. We can't see that type of behavior extend to the lunar environment. That is why it's so important for us to maintain a lead and establish the right norms of responsible behavior from the beginning. By having the military involved, it'll send a strong signal of the nation's commitment and will help deter irresponsible or reckless behavior. As the military has done numerous times before, it can make initial investments to accelerate subsequent civil and commercial activity. None of these capabilities that I'm advocating for are weapons, and I'd like to keep it that way, which is why establishing the precedent up front is so critical. These steps will enable civil and commercial organizations to focus on other challenges that must be overcome in order to succeed on the moon, and it will enable them to take advantage of a foundational architecture. DoD involvement will require additive growth. However, making smart strategic investments now will maintain an advantage and reduce the need for large emergency catch-up funding later. We can't afford to fall behind in the cislunar domain like we lost the advantage in hypersonics. It starts with the development and coordination of a DoD cislunar strategy to define what we'll do and how we'll do it. This will identify the relationships between the DoD and the civil and commercial activities. It will also require a set of guardians, trained and ideally focused on the cislunar activities. Finally, to overcome the challenges that I've described earlier, it's going to require additional investment in key technologies to mature those technologies. Some of the technologies that will be required will become the cornerstone of future cislunar infrastructure. Not having domain awareness, for example, will put future missions at risk and will make it impossible to identify irresponsible or hostile behavior. Communications, of course, is vital to assure connectivity with both robotic and crewed missions and will ensure the relay of important information from different areas of the cislunar regime. Without PNT, coordination and deconfliction of missions and activities will become challenging, and supply and aid will become difficult to deliver for those that need it. Additional technology areas to overcome the distances and conduct sustained operations in the cislunar regime are also needed. Maintaining power to equipment and safely getting materials to and from the lunar surface without spreading regolith will become critical. But once these technologies are mature, we must rapidly transition to operations. This means making architectural decisions as early as possible. This will ensure the right resources and personnel are aligned to support and sustain ongoing operations for the foreseeable future. Without these architecture decisions, we risk losing momentum and jeopardizing the success that we had already gained. Based on the previous discussion, these are my recommendations for the DoD involvement in the cislunar regime. It starts with that broad strategy to chart the course of where we're going to head. Additive growth is essential. These increases in personnel and budget will establish the right foundation for the DoD involvement in cislunar space, but it's just the starting point. We cannot ask the already stretched thin Space Force to pick up additional responsibilities without giving them additional resources. These initial investments will accelerate the achievement of our interests in the race to the moon and help us establish the norms of responsible behavior that we seek. However, periodic reevaluation of these investments and the personnel will also be required based on actual developments, missions, and risks that we're seeing materialize. This new mission growth and the unique challenges require dedicated guardians. New doctrine, concepts of operations, and requirements leading to technologies and capabilities will also be needed to achieve the DoD cislunar strategy. Bottom line, the race is on. Activities in the cislunar regime are happening now and will continue to grow in frequency, scope, and duration. We must be ready and need to move forward now to tackle the numerous challenges facing national security, civil, and commercial efforts. Setbacks and delays should not be viewed as more time, but rather an opportunity for us to recognize that there are unique challenges that must be overcome. This will all require new thinking and growth for the Space Force. The potential implication of China establishing the practices they've demonstrated in the South China Sea to the moon is not in the interest of the United States and the growing list of Artemis Accord partners. It does not bode well for the future exploration of space as we go further. Action is required today to help us move the capabilities forward that we need to not only secure the cislunar domain, but that first island off the coast of Earth, the moon. And with that, sir, I will stop sharing and hand it back over to you.
Thanks, Charles. That's an impressive body of work, and thanks so much for introducing it to our panel and to our audience. Administrator Bridenstine, NASA is clearly in the driver's seat on the return to the moon. We look at our civil programs. When you led NASA, one of your priorities was to establish the Artemis Accords. I was hoping you could provide your thoughts on why that effort was so important, and with the growth in its membership, even with spacefaring nation, what that means going forward.
Absolutely, General, and thank you for having me today. And I do want to congratulate Colonel Galbreath on what I think is a very thoughtful piece on this very important topic. And yeah, so when I was the NASA administrator, we knew that China was going to be not just on the moon, but on the far side of the moon, and it was going to happen very, very soon after I took the helm at NASA. And the question was, what do? We don't have a moon program. And in fact, with the time, we didn't even have a human spaceflight program that was being utilized. So we wanted to get to the moon. We wanted to get there fast. How do we do it? We initially created the Commercial Lunar Payload Services Program, which is how we're going to get to the moon robotically. It was, in essence, it was an extension of the Google Lunar X Prize. At NASA, we couldn't create prizes to get to the moon. We didn't have a legal way of doing that. So we just said, look, if there are scientific instruments that the Science Mission Directorate of NASA would like to get to the moon, How do we employ commercial companies to take those instruments to the surface of the moon? Interestingly, there are lots of scientific instruments that the science community is extraordinarily interested in getting to the surface of the moon. And of course, Colonel Galbraith's paper talks about that. We can do astrophysics from the far side of the moon in ways that we cannot do from the surface of the Earth or even in space, because the far side of the moon is so quiet from an electromagnetic spectrum perspective. Inside the craters of the moon, tremendous amounts of history of the early solar system preserved there. So we wanted to get to the moon. We wanted to get there quickly. We wanted to get there for scientific and discovery purposes. And we wanted to use commercial companies to help us get there. It quickly became apparent that there's a lot of activities that are non-traditional that need to happen in space for which there currently are no rules. And of course, then we move forward with the Artemis program, which was a human return to the surface of the moon. And under the Artemis program, we wanted an open architecture so that how we do things like communication, navigation, environmental control and life support systems, rendezvous and proximity operations, docking, all of these things would be standardized and publicized so that we could encourage commercial investment into these activities. So we would build, NASA would build infrastructure, and commercial companies would come alongside NASA to not just get to the surface of the moon, but to engage in economic activities on the moon. And so we started building these architectures, and it became clear that there really aren't any kind of legal frameworks as it relates to the moon. And we have this outer space treaty that we all believe is very important, but historically there's been no forcing function to compel people to comply with the outer space treaty. And so here we were, and we said, let's get all the nations that are interested in being with us when we go to the moon, let's get them into a room and hear their thoughts and ideas. We had 26 nations come to that first meeting about the Artemis program. 26 countries wanted to be a part of the Artemis program to go forward to the moon. And in these discussions, it became apparent that if we're going to have this much activity on the moon, there has to be some forcing function. In fact, the Artemis program is the forcing function to have nations comply with basic principles and rules that are going to keep everybody safe and transparent on the way to the moon and with activities on the surface of the moon. And so after that first meeting where 26 nations attended, I went back to the office and I said, we have to create a mechanism by which the Artemis program can be, in essence, a tool to compel the behaviors that we think are important for sustainability on and around the moon. And that's how we came to the idea of the Artemis Accords. And we rolled it out with 8 countries that signed on initially. Today, we're up to, I think it's 33 countries, if that's what I saw that Charles had there. So it really is a way to organize nations, and these are all bilateral agreements between the United States and other countries, but ultimately it forms the framework of basically a rules of the road regime where we can all go to the moon safely and transparently. But I would also say it's also the beginning, it's not the end. As more and more activities move forward to the moon, the Artemis Accords are going to have to, of course, be amended and improved over time. So we got the ball started, we got the ball rolling. Now we need to keep the ball rolling, and I think we're seeing a lot of positive developments from the Artemis Accords.
Thank you. A great tour of how we got to the Artemis Accords, and I love the fact that I think you've highlighted in your remarks that you don't have to have a launch capability, a capsule. You don't have to have astronauts to be a part of this team. Your technologies can be inserted. You can team with nations like the United States that have launch and landing capabilities on the moon, rendezvous and prox ops. And it really does bring a great group of nations together with a common diplomatic force to achieve the vision that Charles lays out in his paper. So thanks for that, sir. I think Charles' paper also highlights a long list of technical challenges and political complexities associated with returning to the moon. I was wondering, from each of your perspectives, what are risks that keep you up at night in this regard, and how can we mitigate them? And let's start with the DoD perspective. Mr. Lockhart, if you wouldn't mind weighing in on this question.
Well, thanks, Charles. I think you did a real good job of kind of explaining some of the challenges there. And from a DoD perspective, so we're fairly new. U.S. Space Command started 4 years ago. And so really, we tried to understand the environment. So space domain awareness, Charles put that up. So understand what's up there. And that includes, all the way from LEO, MEO, GEO, all the way to Cislunar. How do you understand that? And do you have enough information? Initially, it was kind of a science community and space situational awareness as opposed to domain awareness. So we kind of put that in priority. And then we said, okay, if we understand what's up there, can we do anything about it? So we actually created what is called combat power. And really it is to influence and kind of make sure the rules of the road are followed. Then once we did that, that creates kind of a dynamic environment. And so now you have to be able to see to it. And so I think, Charles, you hit it. And so in this dynamic environment, how do you command and control? And so those were foundational in our 4 years of existence, were foundational capabilities that we actually put together for ourselves. Space domain awareness, understand what's up there. Second was really power projection. If we had to do something, could we protect and defend? And then the last one is, how do you see do that in that area? The risk, right? So this is a very big, our area of responsibilities, combatant commands have areas of responsibilities. And ours starts at 100 kilometers, 62 miles above Earth to infinity. And so it is a really large area to be responsible and to be secure. And so we're kind of working through some of those ideas, including Cislunar and beyond, and trying to understand that. And so I agree with a couple of comments that this is a starting point, and we're going to learn over time as this gets more complex, more congested over time.
Thank you, Tom. Dr. Mozer, perhaps you could comment on some of the technical challenges that you foresee to do what the things that Mr. Lockhart just described.
Yes, and thank you, and thank you, Charles, for an excellent report. You did a great job, but I'd like to sort of expand a little bit on your basketball court diagram, just to put this all into context. And Mr. Lockhart's right, space domain awareness is a big technical challenge, but if you think about most of the satellites, if you go out at night and look up in the sky and see them flying over, those are in low Earth orbit. That's just a few hundred kilometers above the surface of the Earth. Kind of trivial. Our challenges for space and from a military perspective have been out at geosynchronous, which we call deep space. It's certainly not what Mr. Bridenstine would call deep space, or NASA would call deep space, but objects out 36,000 kilometers away, which is where geosynchronous orbits are, is very, very weak or very dim and hard to track and understand what's going on. So domain awareness just to geosynchronous orbit, which is 6 times the radius of the Earth out, is very difficult. Now, let's go to cislunar orbits, which is 10 times the radius of the Earth and 380,000 kilometers away. The volume of that space, if you think of the full 4 pi steradian volume, because we are worried about activities coming from any direction, you could fit 280,000 Earths in that volume. That's a lot of space. That's a lot of area to have domain awareness, and it's very weak. And oh, by the way, the orbital dynamics are different. There's a 3-body problem affected by the moon's gravitational pull. So very difficult to see, very difficult to predict where things are going. Those are big challenges. So from a security perspective, domain awareness is a big one that we need to get on top of. But there's other technologies too. Things like the communications, the positioning, navigation, and timing infrastructure out to Cislunar. will be important support capabilities. We also need to worry about things like space weather, radiation storms in cislunar environment, and that's some things with a lot of unknowns as well. So the Space Force is really, our task is to organize, train, and equip for places like the Space Command to make sure they have the tools and equipment and methods to deal with whatever comes around. And so we have to do a lot of strategic foresight, looking forward in time. What will the cislunar environment become? Charles described a lot of economic potential and scientific potential. Those of us who are lunar enthusiasts hope that there's a lot of activity at the moon. We want it to be more like the Mediterranean than the Antarctic. The Antarctic's got lots of scientific interest, but there's not a lot of activity going on there. But think of the history of the Mediterranean, lots of conflict and lots of different interests wanting to be there at the same time. So national security is an important thing to organize, train, and equip for now, because those technologies are going to take a lot of time. So lots of challenges, lots of things to do, and now's the time to do them. So, thanks, Charles.
Thanks, Dr. Mozer. Well, we may want it to be like the Mediterranean, but we don't want it to be like the history of the Mediterranean, as you point out, where there was a lot of conflicts. We'd like it to be a peaceful expansion, certainly, and that gets us back to norms of responsible behavior. And Mr. Lockhart and Administrator Bridenstine, both U.S. Space Command and NASA are actively working to establish and enforce norms. Can you describe some of these efforts and how they might extend to cislunar operations? And Tom, we'll begin with you.
Yeah. So one of the things we published was responsible behavior, and it's to space, through space, and from space. And we tried to, make sure that was kind of understood. Debris, obviously, want to prevent as much debris as possible. So if you can influence, encourage, people to kind of stay within the rules of the road, that's also good. And then try not to, we really want this to be a cooperative environment. This, so, and really as we go to, Jim, I think you're nodding your head. And so if we put too much security over the top of this, some of that cooperation kind of goes away, and it actually creates almost like stovepipes of excellence. And we really want that, like the Artemis Accord, have that cooperation with our partners, with our, civil, military, and the commercial side. I do use a rule of thumb, in the Department of Defense this year, our budget's about $30 billion for Space Force. Then we go into, the civil side, and Jim, you probably have the numbers better there, but, you're 10 billion plus. Then we got, a little bit of our international partners, but the big money is really sitting over there in the commercial. It's over $468 billion. And so we've got to figure out how to do that and bring the commercial guys back to open standards. I'm a believer in open standards, model-based system engineering, the ability to kind of share amongst the different communities, understanding our competitors, and they're not always thinking the same way. And so that's kind of what I would throw out there, is to just understand where the money is being invested. And then if we can get, like the Artemis Accords, the groups together to agree on and put those standards out there that everybody can actually use.
Tom, you talked a bit to technical standards. Minister Bridenstine, could you? One thing that struck me when you talked about the Artemis Accords is how they were all individual bilateral agreements with these different countries. Is there something more that needs to be done to establish a broader responsible behavior for framework for all participating nations and commercial partners to deal with?
There's always room for broader engagement, and we did these as bilateral agreements, primarily because going through an international body or an international forum takes a lot of time. There's different interests that want to maybe undermine the effort for their own purposes, and we don't have time to waste. We're going to the moon, and we want to make sure that we're going there with a set of rules that keep everybody safe. As far as avoiding conflict, what we try to do is figure out where are the areas where conflict would occur as it relates to cislunar space. And one of the elements of the Artemis Accords that really is born from the Outer Space Treaty, from 1967, as a matter of fact, is the utilization of resources. And the question is, what are those resources? Where are those resources? And how could that result in conflict? Well, we talk about the water ice, tremendously valuable source of, it's oxygen to breathe, it's water to drink, so it's life support, it's hydrogen, which can be used for fuel. And the water ice happens to be generally it's in larger volumes on the south pole of the moon. So if that's where all of the resources are, and you also have points of permanent light on the south pole of the moon, which is of course important for things like solar power. And I'm not saying solar power is the solution to using the water ice. We're going to need nuclear power on the surface of the moon at some point. But the bottom line is these are small areas. There are areas that have tremendous amounts of resources available for utilization. You're learning how to live and work on another world for long periods of time. That's why we're going to the moon, with a purpose of eventually taking that knowledge and understanding to Mars. When you go to Mars, you have to stay for a period of years, primarily because Mars and Earth are on the same side of the sun once every 26 months. So the value of the moon is that it's always with us. Wherever the Earth is around the sun, the moon is with us. It's always a 3-day journey home. We can do a lot of learning at the moon and then take that for a much longer trip to Mars. But I think those areas where there are natural resources and numerous countries are going to be trying to utilize those resources are areas where there could be conflict. So we created, within the Artemis Accords, we created safety zones. Once you land in a certain area, you have a zone where you can operate without being interfered with. We also applied in the Artemis Accords a principle that I had in the Navy, which is due regard. When you're flying in international airspace and you're being queried by a threat country, potentially, maybe you're in the Persian Gulf and you're being queried by Iran, as long as you say, I'm a sovereign U.S. naval aircraft operating in international airspace, due regard, well, those words due regard have legal meaning in the international world, then it's a not to interfere kind of understanding. And so that principle of due regard is part of the Artemis Accords, and it comes directly from flying in international airspace and operating in international waters. I think that's an important principle. The other areas where there could be conflict, as Charles, I think, correctly showed with his basketball analogy, are those L points, L1, L2, L3, maybe not so much L3, but certainly L4 and L5. And by the way, I want to congratulate Colonel Galbreath for the basketball analogy. I would remind my panelists, who are some of them from Denver, that the Oklahoma City Thunder have now surpassed the world champion Denver Nuggets in the Western Conference, taking the #2 position. So I just wanted to throw that in there. But all that being said, those L points are going to be very valuable choke points, as the Strait of Hormuz is a valuable choke point in the United States Navy. The Strait of Gibraltar, the Strait of Malacca, for example. These are areas where if the wrong people control these very important points, it has huge strategic implications for the United States. And I think the future is going to consider these L points as those types of choke points, and it could result in conflict if we don't have rules, if we don't have domain awareness. And so part of the Artemis Accords is, we wanted people to register their objects that they take to the cislunar domain, so that there is transparency. And if we can have transparency and avoid these types of misunderstandings or misconceptions that can lead to conflict, that's what we want to do. And so we enshrine that in the Artemis Accords as well.
It's excellent. Certainly, we welcome our competitors or even adversaries to join these accords as well, wouldn't we?
100%. And in fact, that was the original intent, was we want to make sure that this is available to everybody. It becomes really challenging, when Russia invades Crimea and then Russia invades broader eastern Ukraine, it becomes really challenging to engage in those kinds of conversations. And then I would also say when it comes to China and NASA's ability to dialogue with China, which I believe is very important. We have a legal regime, the Wolf Amendment, which is put in an annual appropriation bill that prevents NASA from having any bilateral discussions with China without getting approval from Congress, from the Appropriations Committee specifically. It is bizarre to me that the agency that was established for the purpose of diplomacy and the purpose of having dialogue to avert war. We think about 1972. We think about the Apollo-Soyuz program. This was at the height of the Cold War between the United States and the Soviet Union, and we partnered with the Soviet Union on Apollo-Soyuz. And then we had the Shuttle Mir program in the 1980s and early 1990s. And then we had the International Space Station. NASA has a history of doing great diplomatic work to create channels of communication and dialogue that I think is necessary to avert war. So the answer is absolutely. NASA would be the right agency to have these types of discussions directly with China. Currently, NASA is prohibited from doing that by the Wolf Amendment, which I think is short-sighted.
Thank you. Tom, even if our adversaries were to sign on to these accords, the words of Ronald Reagan, "Trust but verify," come to mind. And it seems to me that would be a key role of the Department of Defense. You talked earlier about we need to be careful not to be too heavy-handed to discourage cooperation that could discourage cooperation or people joining into the exploration and advancement to the moon. I was wondering, could you give us a little more of your thoughts on what the role DoD should play and what the boundary conditions might be for their participation in securing this area of cislunar space and the moon, and making sure it's treated like the air domain and the sea domain here on Earth?
Well, and so I think we're learning, and I'll also look at Dr. Mozer, but 4 years and kind of going, we're seeing a lot of LEO propagation, congestion, and so back to this conflict, right? The more players you have on, I probably should use a basketball analogy since Jim did that. So hey, Thunder and Nuggets, what we did is we were competing to help one another out, right? As opposed to competing to win. And so I do think we want to stay in that competing to help one another out, as opposed to that win scenario, because that's usually a bad day when we have to use some non-kinetic effects or kinetic effects on any kind of adversary. Now, how do we enforce it? That's the real question here. Can you data share? Just, one of the things that we've been putting together is our commercial operations that right away we say, hey, we think something's going on here and we want to share it with as large an audience as possible. That way, it's calling it out. Hey, you shouldn't be doing that kind of stuff. And so that's a perfect world. And then individuals react to it and say, okay, yeah, I shouldn't be moving that fast or moving into that area or encroaching on somebody else's territory. The second part is, then you get something up there that kind of protects and defends it. That may be an alternative. And we did that with our shipping lanes, right? So we had commercial shipping lanes, and sometimes we used military to kind of help them out as they go through different straits. So similar type of activities, think about protect and defend. And then the worst case scenario is when a conflict actually occurs and you have to do something about that. Sir, you know this better than anybody. Those are really tough calls, because once you enter into that, Some things escalate, which you really don't, you want to de-escalate, and you don't want to get to a large conflict, right? So hopefully that kind of covers it. You know, we do have in our capabilities documents the ability to go from non-kinetic effects, the ability to kind of say, hey, don't do that, and we're going to kind of push you a little bit all the way up to that kinetic, effect if we had to do it.
Which obviously you'd never want to use, but that is kind of the model of the U.S. Navy on the high seas. They have a capability that they don't want to have to use, but they're a necessary presence to maintain freedom of commerce on the high seas today. And we're seeing that play out in the Middle East right now. Well, this has been a great discussion, and I want to leave a little time for Q&A from our audience. But before we turn to them, I'd also like to get any closing thoughts or from our panelists today before we move on to the Q&A. And so, Dr. Mozer, why don't we start with you?
Yeah, thank you. So the cislunar space is, it can seem very far away, and I talked earlier about how vast the space is, but there's also some near-term concerns and some smallness of the moon that we need to consider. Which, let me express that a little bit more clearly. So Administrator Bridenstine talked about how some of the water is concentrated on the south pole of the moon. In fact, a lot of the resources that are of interest are on a small little area called the Connecting Ridge that's adjacent to Shackleton craters, just a few kilometers on the side. And that's where folks are going today. There's a race to the south pole of the moon, to the Connecting Ridge. And it is possible that, without norms of behavior, even in accordance with the Outer Space Treaty, the first person there could get there and put up a fence, a safety zone to keep other people out that's fully consistent with that. So it's not so much arbitrary and esoteric. These are problems that will play out over the next couple of years. So there's some sense of urgency here. And I'd just like to say one last final thing is, there's a soft power and people part of this too. The Apollo era inspired a generation of engineers and people to go into science and technology because it was exciting, because we were competing with our strategic competitors. The same thing is true. The technologies that came from Apollo, from everything from fireproof suits to integrated circuits, have driven generations of other technology development. And there's no reason to expect that the same won't continue as we go back to the moon and do those things. So we want to be out on the technological edge of that, or on the forefront of that, and create the norms of behavior that produce those benefits for the world. Thank you.
Thank you, sir. And Mr. Lockhart, any comments from you?
No, I think we're beginning this journey. I wrote a paper called Hitchhiker Guide to the Digital Galaxy. We're just at that forefront. And so we're learning a lot as we kind of develop ourselves. 4 years in running. We do appreciate the relationship with our NASA partners and what they're learning and how they're putting those relationships together, because I think that may be a model for what we're doing in the Space Command. So I do think that's really, really important. I do think we want to stay on the cooperation side as much as possible and avoid the conflict side. But if called upon, we'll be ready.
Thank you. And Administrator Bridenstine, if you'd like to close us out with any final comments.
Sure, I would just say Colonel Galbreath, I think, hit the balance just right as far as cooperation, and that is that what does the Space Force need to be developing? It needs to be developing communication, navigation, and really sensing and or domain awareness. Those are all things that are not combative in nature. They're things that increase transparency, enable us to go to the moon with commercial partners, with international partners. And so I think that is the right approach. And I think Colonel Galbreath hit it just right. I would also say in this paper where he very clearly articulates that this is not dissimilar from the early days of air power and the utilization of air power. And there were great debates. In fact, this organization, the Mitchell Institute, is named after Billy Mitchell, who talked about the importance of air power in future wars. And of course, that was very controversial in that moment in time, to the point where he even got fired from his position. but there we were in World War II, and we were doing strategic bombing from an aircraft carrier with a B-25 aircraft named after Billy Mitchell. He was right. He was way ahead of his time. And I think what's important about this organization, the Mitchell Institute, is you guys are thinking 20, 30, 40 years down the road and saying, what do we need to do today? And this is what Colonel Galbreath outlined in the paper. What are the small investments we can make today that will prevent massive investments in the future? And I think that was the message I took away from Colonel Galbraith's paper. And I think it's important for everybody who has an interest in these things to read and understand what those principles are.
Well, thank you very much, sir, and thanks to all our panelists. Now we've come to the point in the program where we turn to Q&A from the audience. And Aidan is going to assist us here by either reading texts that he's received or by introducing audience members who are on the broadcast today. And just a reminder to unmute your mic and please state your name and affiliation before asking your question. Okay, Aidan, over to you.
Thank you, sir. First, we have a question from Sandra Irwin of Space News for Mr. Bridenstine. Do you think there's support at NASA for military involvement in cislunar space?
I mean, you think about the history of NASA and the Department of Defense going back to the Apollo era. There's been a lot of collaboration. We think about even today, a lot of our astronauts come from the United States military, all branches. So I think the collaboration is there. I think it's important that NASA is not going to be involved in providing domain awareness as commercial activities go forward to the moon. And by the way, there are a lot of commercial activities that I believe are going to happen at the moon that are not just based on resources. It's about the 1/6 gravity well of Earth. What are the opportunities with having a gravity well that is 1/6 that of Earth, where the radiation environment is more benign because you've got shielding from the moon itself, and you can get under the surface of the moon. So there's a lot of economic activities there. NASA does not do national security and defense. It is not who NASA is. It's not our legacy. President Eisenhower specifically would not allow NASA to be created if it was done within the Department of the Army or the Department of War. He said it's not going to happen that way. It's going to be independent. And so NASA is not a tool of military power when you think about DIME, diplomatic, information, military, and economic. However, NASA is a tool of diplomatic power. It's a tool of information power. It's a tool of economic power. And all of those things are not achievable without the security in place. So I think largely NASA understands that security is critically important. And yeah, I think they welcome the idea of having domain awareness, communication architectures, and navigation capability.
Next, we have two related questions, one from Jonathan Daigle of the National Space Society. He asks, can you discuss the duality of safety zones or non-interference zones, which can ensure safety of missions, but could also be used to try to exclude other actors from an area? How can this be balanced or resolved? Similarly, we have a question from Alec Robinson of how do the Artemis Accords deal with the establishments of close orbits in L4 or 5, where they could become a de facto occupation of choke points under a due regard doctrine?
Yeah, so I'll take both of those really quickly. The reason we have the Registration Convention in the Outer Space Treaty from 1967 is specifically so that there isn't any, it's transparency. It's to avoid any misperceptions that can result in conflict. That's why we have the Registration Convention as part of the Artemis Accords. If you're going to go with the United States to the moon, we want you. We want all players to go to the moon with the United States. It's also true that if you're going to be with us, we need transparency, and we need folks to follow the Registration Convention, because that's how we avert war. As far as the safety zones, the idea is to enable more people to have more activities on the surface of the moon, and for private companies and international partners to be able to utilize the resources of the moon. So the idea is not to exclude or keep people out. The idea is to enable people, numerous entities, to be able to get to and utilize those resources. And I want to be also clear that the Artemis Accords are very basic, and they should not be considered the final form. In my opinion, as time goes on and we have more and more activities and we learn more and more, there's going to be more frameworks that need to be put around each of these very important items. You know, I live in Oklahoma, as I mentioned earlier. You know, there was a day when Oklahoma was legally prohibited from being settled. And then there was this group of folks called the Boomers, and they went to Washington, D.C., and they lobbied hard for the settlement of Oklahoma. And Congress passed a law that enabled, you know, if you can get to a lot of land, I think it was 40 acres, it might have been more, I can't remember, but if you could get to a lot of land and you could homestead on it, you could set up a house on it, you could develop the land, you could farm the land, you could use the land for agriculture, you could claim and have that as a resource available to you. And what happened is, as soon as that law passed, the Boomers became the Sooners, OU Sooners, for example. The Boomers became the Sooners, and all of a sudden, Oklahoma City had 10,000 people. Guthrie, Oklahoma had 10,000 people. You had, you know, 10 banks and, you know, 5 newspapers, and all of this development happened because the resource was enabled to be utilized. And I think if we want to go forward to the moon, we have to enable people to utilize those resources. And if we're going to enable people to utilize their resources, there has to be a methodical way within a rules-based framework for people to go and utilize those resources. By the way, we've been talking about the water ice. There's a lot more there. Colonel Galbreath talks about in his paper as far as what the value of the moon is that could be even more significant than the water ice.
Thank you. We have also a question from Marco Tentardini. He asks, what architectural elements could the U.S. Space Force engage with partners and allies that signed the Artemis Accords to promote this vision of cislunar space? Would this cooperation be done via a DoD to Ministry of Defense counterparts, or it's instead of a NASA to other space administration cooperation?
I can take a quick swing at that one. So things like communications mechanisms, so communicating out to lunar space, it's not trivial. Infrastructure to transport mass back and forth if we do get resources, position, navigation, and timing. Those things could be inherently international, and we could cooperate to develop those things. From a DoD perspective, just as we cooperate with our NATO allies for surveillance and observing to have domain awareness, we could develop the same sorts of things in cislunar space, where we develop the radars, the telescopes, the other sensors that detect and track things in cislunar space together. So there's plenty of opportunity. And another area where we could have early international cooperation is traffic management, orbital debris kind of stuff, things that we are worrying about today in low Earth orbit. We can get in front of that in cislunar orbit today in an international way.
Yeah, if I could, along those lines, I advocate for the use of transponders to basically be a beacon of where you are, to eliminate some of the need for our space domain awareness architecture to do the search and detect mission. If we can have some active notification of where objects are and how they're behaving, that in a cooperative sense will make that domain awareness mission so much easier and increase transparency and cooperation overall. So that's one example of something we can do differently in the cislunar domain than we've traditionally done in the geocentric domain.
Kind of like AIS in the maritime domain, where
Absolutely.
ships broadcast at sea their location, and that makes it much easier to have situational awareness of that vast domain here on Earth.
Absolutely.
Very good. Thanks,
And
Charles.
and also,
Please.
General, it helps you know who's nefarious.
The people who turn it off.
Right.
That's exactly right.
I was thinking
Exactly
along
right.
the same lines, aircraft traffic management, right? So we have, trackers that are actually on there and and the traffic collision and avoidance system, we actually are getting pretty accurate where we have 500 vertical feet separation for certain aircraft. I think you could probably think along those same lines on transponders.
Yeah, that makes such sense. I think back to the question, though, I think my sense is there's room for both diplomacy at the agency to agency level, civil space level, but also in the DoD, MOD level as well. Those dialogues have to occur to get good agreement and understanding of what the environment needs to be like to be safe to operate in, both from just a safety perspective, but also from a rules-based perspective. So I think that would be, I think we all talked around that a bit, but I think that's probably the right answer to the question. And with that, ladies and gentlemen, I'm really sorry we've come to the end of this rollout. Administrator Bridenstine, Mr. Lockhart, Dr. Mozer, thanks again for being here. Just a rich discussion today. Thanks so much. Couldn't have had it without you. And to Charles, of course, thanks for all the work you did on this great paper, which for our audience is now available on our website at mitchellaerospacepower.org. That's mitchellaerospacepower.org. Really encourage you to go check it out and read it. And for all who took time to join us today, from all of us at the Mitchell Institute, we want to wish you a great Space Power Day.